Okay, so the best tool to practice any chapter is paper 1 MCQs. It can help you to learn all the definitions, laws, reasoning, justification, analysis, calculations, evaluations. Everything is tested here. So electricity, both chapter 9 and 10, I'm going to now discuss with you. And please hold a green or red pen while you are doing your corrections. Okay, so question number 1. An electrical conductor has a resistance 5.6 kilo ohms. Potential difference is 9 volt. And how many electrons? Number of electrons is capital N. So what do you do? The capital N, when you want to find, we say Q is equals to NE. We say Q is equals to IT. So number of electrons could be found using this equation. So number of electrons will be current multiplied by time over E. So our first task is to get current. So current you can get I is equals to V over R. I is equals to 9.0 over 5.6 kilo. I is negative 3. This is the current, my dear. Once you got the value of current, you can substitute here. So 1.6 10 power minus 3 time, they say 1 minute. 1 minute means time is 60 seconds. So you multiply by 60 divided by the E. E you take from the formula sheet 1.6 10 power negative 19. The right option is 6 into 10 power 17, option C, my dear students. What are the assessment objectives here? Now look, this question is called like medium to higher order of thinking. Assessment objectives are how to relate the equations, 2 different equations of charge, plus 1 equation of V is equals to IR. Okay, it's a good question. Question number 2, my dear students, as you can see, the fixed resistor has a resistance 12 ohms. The current is I 0.2 ohms. Okay, now they say, now the current is doubled. Current is doubled. What is the new power? Very easy, lower order of thinking question. Okay, power is equals to I square R. Current is doubled, 2 times 0.20 square times the resistance. The answer is 1.92. This is easy question. This is called lower order of thinking question. Okay. Question number 3. Question 3 says, my dear students, which measurements are taken to calculate? This is not easy question. This is a difficult question. Those who did correct, I really appreciate them. Why? Because the trick to this question is measurements. Measurements mean raw quantities, raw values. So which measurements can be used to find resistivity? Resistivity is rho L over A. Can you measure length directly? Yes. Can you measure area directly? No. So for area, you need pi d square over 4. So you need diameter. You need diameter. Can you measure resistance directly? No. To measure resistance, you need the voltmeter reading and current reading. So these are the raw values you need to take measurements. So you need PD, you need current, you need diameter, and you need length. My dear students, this question is challenging, my dear, until a student sees the answer from mark scheme. So answer will be a PD, current, length, diameter, option B. Many students, they will choose directly option C, which looks like correct because rho is R L over, rho is RAL actually, it's a wrong formula. It is R A over L. So length we need for area and for resistance. Okay. So resistivity is RAL, R A over L. Option is B, my dear students. Question number 4. A battery of 12 volt, okay, 20 minutes. 20 minutes mean time will be 20 multiplied by 60, 1200 seconds. This is the energy, okay, and this is the voltage, okay. You want charge Q. We don't need time. We don't need time. You know, my dear students, the EMF or the voltage, both are defined as, both are energy per unit charge, my dear. So charge could be directly found energy over voltage. We don't need the time. Energy is 7.2 10 power 4 over time. Sorry, voltage is 12, which is 6,000. Option D, my dear students. A good question. Medium order of thinking. Question number 5, my dear students. Question 5. A battery of car has internal resistance is called lowercase r. Okay. And EMF, it's called uppercase E. The battery is connected to the starter motor. The potential difference of terminal is called V. VT you can say, or V you can say. What is current? We have only one equation which says E is equals to V plus IR. Yes, my dear students, E is equals to V plus IR. Substitute the values. EMF is 12, voltage is 7, I we don't know, R is 0.10. So 5 is equals to 0.10 I. So I will be 5 over 0.1, which is 50. Option A, my dear students. A good question. After this lesson, you never need to worry about electricity. Question number 6, my dear. Question 6 says the three cells of EMF V1, V2, and V3 have negligible internal resistance. The cells are connected to three resistors, which are R1, R2, R3. Okay, current is I. Which equation is correct? Loop equation. Kirchhoff's second law you apply. Kirchhoff's second law says in a closed loop, sum of all EMFs is equal to sum of all PDs. I am taking the loop. It's your choice, but I'm just taking the loop this way. Okay. No, you can take opposite. When there is a single battery, you can take in the direction of current. When there are multiple batteries, it's your choice. Okay. I can take the other way. You want me to take the other way? I can take. No problem. So okay, sum of all EMFs is equals to sum of all PDs. EMF, okay, now this is leaving positive terminal, so V1 is positive. This is leaving negative terminal, V2 is minus. This is also leaving negative terminal, minus V3 is equals to I R1, I R2, I R3. So you factorize I, my dear, R1 plus R2 plus R3. The correct option is D, my dear students. Make sense? Sure? After this, question number 7. Three resistors, each has resistance R. They are connected as shown. Total resistance is this. Find the value of R. Easy, my dear. Go for series. Series is 2R. Yes? 2R is parallel with R. You can do product over there. Sum is equals to 8. Up is 2R square. Down is 3R is equals to 8. 1R simplified. So 2 by 3R is 8. Cross multiply. R will be 8 multiplied by 3 over to 12. Question number 8. In driving the formula of combined resistance of three resistors in series and parallel, let me tell you. I told you when you use Kirchhoff laws to prove series and parallel. For parallel, we use first law. For series, we'll use second law. S for series, S for second law. This is easy to learn for your life. Okay. So to prove the combined resistance in series, you have to apply Kirchhoff's second law. Is there any option? Okay. If no option, let's explore it. Kirchhoff's second law. Second law is voltage law, which is called conservation of energy. Conservation of energy. The first law is current law, which is conservation of charge. Now let's say which physics is involved. Conservation of charge? No, it is first law. No, it's first law. First law is the current law, which is used for parallel circuits. Okay, so current, the direction of flow of charge is from negative to positive. No. The potential difference across each resistor is the same in series. No. Current varies in each resistor proportional to the value of series. Go for that. Series, first of all, you already know what? Same current. If current is same and within same time, the charge is also same. So is there any option of same charge? Yeah, it is this. Charge same in charge is conserved. What is meaning of conservation? Something remains constant. Huh? Yeah, true. Also, the current is same. There is no junction. Every point, it has both laws, my dear. But there is no, all other options are not valid here. Parallel, my dear, we also have the junctions, my dear. Okay, we use the first law. True. 100% we use. Why? Current entering into a junction is equals to leaving. Series, the current is the same. If current is same, the charge is also same. Option A, my dear. Question number 9. Question 9, my dear students, they say the resistors are connected as shown. What is the total resistance? Let's go each branch. So this is the first branch, as you can see. As you can see. So the first branch is 28. Next branch, 14. The last branch, 7. So 1 over 28, 1 over 14, 1 over 7, whole power minus 1. Please calculate. 4. Option C. Series we add. The parallel, I added the reciprocals and tell power minus 1, my dear students. An electric current I is given in the list on the page number 3. Leave. This is the formula. A and VQ. What is A? A is area of cross section. N, number of free electrons per unit volume. That's it. V is the drift speed. Q is the charge. B. Very easy question. Question number 11. 11 says the potential difference across the resistor is 12 volt. Current in the resistor is 2 amperes. You have V, you have I, you have charge Q. What is energy transferred in the resistor and the time? Energy transfer, my dear, it is VQ. What? Voltage into charge. V is how much? 12. Charge is 4. The answer is 48. Time. You know, my dear students, the current equation that QI is equals to Q over T. The time will be charge 4 divided by I, 2. The answer is 2. Option C. Easy question. Yes, my dear students. Question number 12. A coil has N turns of insulated copper wire that is wound on the cylindrical iron core of diameter D. The copper wire has a diameter D. The resistivity is rho. The diameter capital D is much greater than the small d. What is the total resistance? Resistance formula, my dear students, now pay attention, is rho L over A. Rho L. L is how much? Now, if this was in the form of a coil, yes, it has n turns. So one loop of coil, okay, its circumference, the length of the coil for one loop will be 2 pi r. Yes, and 2 pi r means 2 pi radius is diameter over 2. 2 cancel with 2. So one loop is pi d. One loop is pi d. So my dear students, the total length will be how much? Total length will be n multiplied by pi d. So it is n pi d is the total length. Why? Because the length of wire for one loop is pi into d. Total number of loops is this. So instead of length, you will put n pi d divided by area. Area of cross section in terms of diameter is pi d square over 4. Double denominator is multiplied up like this. It becomes 4 rho n pi over 1 diameter will be simplified with the square. So denominator will be pi d. Now you need to look which option is this. My bad. This is uppercase D, okay? This was uppercase D. And down is the wire. Okay, that's it. So simplify, my dear students. Pi will be cancelled. So up will be 4 rho pi gone 4 rho n d over d square. Option A. Okay, Akram is saying, why did I use capital D for the loop? My dear students, to find the circumference of the circle. Yes? Yes or no? You need radius. So this diameter is uppercase D, my dear. The circumference of the circle, it uses the uppercase D. Okay, question 13, my dear students. Two cells are connected to a load resistor of resistance 3 ohms. EMF and internal resistances are shown. Calculate the current in the load resistor. No problem. Kirchhoff's second law. Apply Kirchhoff's second law, my dear. Loop direction I will take according to the batteries. Positive, positive, yes? So I'm taking this way. Yes? So sum of EMFs is equals to sum of PDs. EMF are both 3 plus 6. PDs I, can I directly do R plus R plus R? 9 is equals to I times 5. 5. 9 divided by 5, I, which is 1.8. Here we applied Kirchhoff's second law. Sum of all EMFs is equals to sum of all PDs. Next question, number 14. This is very easy. Let's see what is your approach. I will just tell you my approach. These all are identical. R, R, R. Sorry, it's written each has R. R, R, R. You need combined resistance is 66. What? 66 kilo. Okay, these three which are in series, parallel, if they are identical, you say R over 3. Yes? These two are parallel, they are identical, you say R over 2, and this is R. Now these three are in series. So what will you do? R plus R over 2 plus R over 3 is equals to 66 kilo. I will keep kilo. Use your calculator. 1 plus 1 by 2 plus 1 by 3. 11 by 6R is 66. So now you will calculate 6 times 66 over 11, 36 kilo. So, dear students, what you do, identical resistors in parallel, I told you, you divide by number of resistors. So R plus R by 2 plus R by 3 is 11 by 6R. And then what do? Equate with 66 kilo, you got 36 kilo. That's the right approach, my dear. Next question, number 15.
Yeah.
A potential divider circuit consists of two resistors R1 and R2, which are connected in series across the source potential difference PD, which is Vn. The potential difference of R1 is V out, which changes will increase the value of V out. So now, my dear, very easy. Don't look at the options. You want to increase V out, yes? There are two options. Either you can increase V1, R1, or you can decrease R2. Please check. Okay, R1 should be increased, R2 should be decreased. Also, my dear, in the answer key, the option was written a different one. It is B. It is B. You can fix it, my dear students. You got it? Did you understand, my dear students? It's easy. Question number 16, my dear students. The diagram shows a simple circuit. Which statement is correct? When the switch S is closed, the EMF of the battery, okay, let's check. When you close the switch, EMF falls. No, my dear, EMF remains constant. Terminal PD can change. So option A is, they are saying false. It's wrong option. Option B, they also say EMF what? False. It is a wrong option. So A and B are ruled out. We have C and D to discuss. When switch is closed, the potential difference across the battery falls. Let's read. Because the work is done against the internal resistance. Yes, this is true, my dear. Why? Because you know terminal potential difference is EMF minus IR. Yes. So when switch is closed, there will be current. Due to current, some PD will be lost in the internal resistance and it will fall, my dear students. Option C is correct. Okay, option C is correct answer. Question number 17. A resistor has a resistance R. When potential difference applied across it, it is V. Voltage V, resistance R, current is I. Which formula is not a valid relationship? Let's check. First says P is equals to VI, right? It is valid. Then Q is actually the work done. You know the equation that the voltage is what? Amount of work done per unit charge. So is charge work done over voltage? Correct. It's energy. Now, C says P is equals to I square R. It is also correct. D is saying P is equals to, sorry, D is saying P is equals to V over R. No, it should be V square over R. So D is the wrong one. They wanted us to choose the wrong. It is D. Easy question. The next question, a wire, question number 18. A wire has a resistance R, diameter lowercase d, resistivity rho, length question mark. You know, my dear students, resistivity is RAL. Resistivity is R A over L. So L will be R A over rho. Put the values. R is 9.8. No, we need to find L. 9.55. A we already know, my dear, pi d square. Pi D 0.280. Millimeter mean 10 power minus 3. Pi d square over 4 divided by resistivity 4.90, 10 power minus 7. Dear students, the area is pi d square over 4. So this area, as you can see, pi d square over 4. This is a higher order of question because conversions as well as rearrangement of equations are needed. So this is, you can just calculate. It's A. So what did we do? We converted the millimeter into meter, which is 10 power minus 3. Pi d square divided by 4, it gives you what? Area, and then you substituted the values. Question number 19. Charge carriers of charge Q through a length, the density, number density is N. What else is required to determine average speed? No problem. Drift speed V is equals to I over Nia. Nia, instead of E, they are using letter Q. Instead of E, they are using Q. Okay, now you have what? Charge Q you have? And you have, so we need I over A we need. We further need I over A. Current per unit area, yes. Because everything else, we need I over A. So I over A is current divided by area. Option is A, my dear students. Question number 20. Question number 20. Potential divider circuit is constructed with the variable resistor X and a fixed resistor Y. Okay, the potential difference across X is Vx and Y is Vy. A resistance X is increased, what happens? Don't look at the options. If you increase the resistance X, yes, Vx will increase. Vy will decrease using the rule of potential divider. Let's check which option. Vx rises, Vy falls, C. It's a very lower order of thinking question. Straightforward, read the question, apply your knowledge, get the answer. Okay, it's C, my dear students. Question number 21. A beautiful question, a higher order of thinking question. And you all will tell me if you were able to solve this question or not. A cell of EMF E is having internal resistance, which is negligible, internal resistance, as shown. The voltmeter has a very high resistance. High resistance means it doesn't, even they tell you or no, mean it doesn't draw a current, okay? And the voltmeter is across 4. What is the ratio of V out divided by EMF? A good question. So let's solve, my dear students. The voltmeter is across 4 ohms. Yes. Right now, the trick is these two are in series. By looking, they have same path of current. They are in series. I will make for you this circuit in this way so that you can understand. This circuit is actually this circuit. And here is the voltmeter. 12, 2, 4. This is the circuit. So, my dear students, I rearranged the circuit and I made in this way. Now you can know the EMF ratio into this. 12 has no contribution. 12 has no contribution to your question. Why? 12 is parallel to the EMF. 12 has no contribution to your question. Yes. Now why? Because it is so easy. EMF. Use potentiometer rule. What is this total? 6. And okay. So 6 ratio. What do we say? Hold on. We say V1 over V2 is equals to R1 over R2. Instead of saying 1, 2, I will say V1 over V total, R1 over R total. Yes? V1 is the voltmeter. V total is the EMF. R1 is the 4. Yes? R total is 6. 6. I don't know. Let's solve it. What do you want? V out? So V will be 2 over 3 into EMF. The option is 2 over 3. D. Don't make it complicated, my dear. We did not consider 12 at all. 12 is already parallel. 12 is already getting full EMF. E. EMF, voltage, they are same in parallel. So we are comparing the last branch. This branch. This total voltage is 6. Total resistance is 6. Total voltage is E. So this voltmeter is 4:6, which is 2:3. Okay, so answer is D, my dear students. Let's go to 22. Question 22, the resistors are connected in parallel. The power dissipated in each resistors 2, 3, 4 is P1, P2, P4. P2, 3, 4. What is their ratio? No problem. Power has many equations. P is equals to I square R. I cannot use because current is different. Okay, P is equals to V square R. I can use it. Why? Because V is same. So it means power is inversely proportional to resistance. So P2 ratio, P ratio will be opposite to the resistance. Yes or no? Opposite to the P2 ratio, P3 ratio, P4. It will be R4 ratio, R3 ratio, R2. Why, my dear? Because it is inversely proportional. When two quantities are inversely proportional, their ratios are opposite order. The ratios are opposite order. You need power 1, 2, 3, 4. So ratio will be resistance 4, 3. Okay. So question is V square over R. Actually, they are not 2, they are 3 ratios. V square over how much R? 2. V square over 3. V square over 4. So V square simplified 1 over 2, 1 over 3, 1 over 4. Multiply all of them with the common factor, multiple. What is their common multiple? 12, 12, 12, 12. 12 over 2, 6. 12 over 3, 4. 12 over 4, 6, 4, 3. Option C. We just did it in front of you. So what do? P is inversely proportional to R. We wrote 1 over R1, 1 over R2, R over 3, and we simplify the ratios. Option is C, my dear students. Make sense? Harder. Again, once again. There you go. You need power 2, ratio power 3, ratio power 4. Power is inversely proportional to resistance. So 1 over resistance 2, 1 over resistance, 1 over resistance 4. Now, how do you simplify the ratios? You can multiply them with their common multiple. So their common multiple is, you can multiply ratios by any number. I will multiply by 12. Why? Because 12 is their LCM. So 6, 4, 3. Option C.
Multiply all of them by one number.
Yeah, just like IGCS is simplifying the ratios. You can multiply or divide by same number each time. The option is C. Okay, question number 23, my dear students. Which graph shows the variation of current potential filament? I can tell you, filament bends away from current. That's it. Filament bends away from current. Away from current is A. Okay. Anyhow, let me tell you other graphs also. B is a fixed. or metallic resistor, right? That is called ohmic. Mixed metallic is that. Okay, then you will say A is non-ohmic. I'm giving you the name. This is filament or heater or lamp. The C we didn't study, although the diode, but the diode is this is diode. Let me tell you, this is diode. Dear students, here you got everything. Yani all four graphs are here. So they tricked you. You remember when I was teaching you the lesson, the syllabus requires IV graphs, but they flip the axis to confuse you. So the best way to learn is the filament bends away from current. Thermistor bends away from voltage. Diode has a intercept on voltage axis and bends away from voltage. That's it. A wire of cross-section area, dear student, that's a good question, my dear. We did it. Okay, cross-section area you have, resistivity you have, voltage you have, current you have, length you want. To find the length, first find the resistance. R is equals to V over I. Voltage is 6. It's an easy question, medium order of thinking. 2 ohms is the resistance. Now, my dear students, you know the rule, length. You know, resistivity is RAL, RA over L. So L will be RA over resistivity. Put the values. Resistance is 2. Area is 5.0 times 10 power negative 6 over resistivity 50 times 10 power minus 8. Solve, my dear. Sorry, 20 meters. The electric current in a wire may be calculated. I is equals to actually NAVQ. It is the same equation, NAVE. Yes? NAV. We did like this. Yes? NAV mean number density, area, velocity, charge. Which statement is not correct? Which one is not correct? Yani wrong statement you need to choose, my dear students. N is the number of charge carriers per unit volume. This is the correct statement. N times A is the number of charge carriers. This is a tricky to understand. We need to know. Hold on. Maybe this is also right. NA. N is number of charge carriers per unit volume into A. N volume is area times length times A. Area simplified. It is number of charge carriers per unit length. It is correct. It is correct, my dear. It is also correct. Now let's go for C, my dear students. C is Q is the charge on each carrier. Also correct. V is the velocity of charge. No, it is average drift velocity or average drift speed. My dear, no, it's not velocity. Who told you it is velocity? It is the drift velocity, which is mean velocity. Please don't mix it up. The reason, my dear, it should be what? Average drift velocity or speed. Good question. It's a very good question. My dear, A, B, C are 100% correct. When did you say velocity of electrons is this? You always say drift. Oh, hold on. Let me take you back to the previous question. Where was that? Page 2? See? What did we choose? Option B? Average drift speed or average drift. We will never see this velocity. You had one more question here. Where was that? I just want to make sure that you don't do a mistake. Read the sentence. Average drift velocity. So as I told you, it is average drift velocity or average drift speed, my dear. It's a good that you realize. My dear students, at the beginning of lesson, I told you, if you want to consolidate any of the chapter in order to bring full marks in theory, just do MCQs. Everything is there. Everybody, you can ask your seniors. Always I do that. Okay. Next, a cell of internal resistance is small r. EMF is E, connected in series to the R. Okay, the question is the resistance R, EMF, E, they remain fixed. So internal resistance R of the cell changes with the time. What is the best graph that shows the variation of the current with this? I can handle this question with the help of equations. Yeah, the equation E is equal to V plus IR. I can do in that way also. So let's study. So you know E is equals to what? V plus IR. Yes or no? Now you want the relationship of current with internal resistance. Yes? Make the subject IR. Which will be what? E minus V. I is subject on y-axis. E minus V over R. Inversely proportional. What? Inversely proportional now, two options we cross. It can be either A or B. A tells you, so why did I cross? Because inversely proportional graph is always a curve. Yeah, but now the intercept. The problem is intercept. Now substitute the values. Now the option A says when internal resistance is 0, current is infinite. Can be current infinite? No. A says when your internal resistance is 0, see, is there any current? It says there is infinite current. Can current be infinite? No. So when there is internal resistance, there is a value of current. Current must have a certain value, my dear. So option is B. Okay, listen again. Your key to the question was this rearrangement. Okay, this rearrangement tells you that the I inversely proportional to internal resistance. Yes, so you need to have a curve graph. So that's why you cross C and D. Now you have options A and B. Both seem right. A says when resistance is 0, current will be infinite. No, my dear, if there is internal resistance 0, the current will be a number, which is a maximum value. Question number 27. Easy. There are two ways to solve this question. One is your general knowledge. Other is assuming the numbers. What do you want? Assuming numbers or just your knowledge? Knowledge says series is maximum, parallel. Okay, both ways. Numbers I will do. Knowledge says series is maximum. The parallel is minimum. So this one is minimum, yes? And the series is maximum. Maximum is P, minimum is R. Option A. No, honey wants numbers, no problem, my dear. Let's do numbers. So numbers, I'm going to assume 2 ohms, 2 ohms. This gives you 4. 2 ohms. 2 ohms, 2 ohms. This gives you 1. 2 ohms, 2 ohms gives you 1. 1 plus 2 gives you 3. Okay, again. So maximum is 4, and then 3, and then 2, and then 1. A. Yes, my dear, you can assume numbers or use your knowledge. That's it. Good question. Question number 28. The circuit consists of the two resistors, 10 kilo and 50 kilo, and voltage is 6. And the electric potential of the bottom is 0. Okay, the current in the component Y is negligible, just like before we did voltmeter. So what's the electric potential at junction X, my dear? Now X, you need to talk about with respect to what? With respect to lower terminal or with respect to upper terminal. So X is connected to what? Lower terminal or upper terminal? Lower. So 50 over 60 times 6, which is 50 kilo, 60 kilo. So 5 volt. D. What's the problem? Ratio is also correct. Option is D. Question number 29, my dear. The electrons move in a vacuum in a metal plate to another. As a result, there is electric current 48 micro. Okay, and the current, this is easy question. This is time. Time is multiplied by 60, so answer is 300 seconds. Two equations. Dear student, Q is equals to NE, Q is equals to IT. So N will be IT divided by E. I, 48 micro. 48 micro mean 10 power negative 6. Time is 300 over E, 1.6 into 10 power negative 19. D. This was an easy question. I don't rate it as a difficult one. It's a very common IGCSE concept. Question number 30, my dear. A battery is connected to three resistors, 12, 6, 2. Current in battery is 3. What is the power dissipated in the resistors of 6 to 2? Actually, power dissipated depends upon either VI, I square R, or V square over R. Yeah. Now, resistance we have. So you need a relationship with either you need I square R or you need V square over R. Both are correct. So in either case, you need to find there. I will go for this one. I will go for why? Because it is easy for me to find there. Yeah, voltage share I can find. Then I need individual currents. I can also do that. If I am choosing one, tell me which one should I choose. I will do for you. Habibi, I will choose for you that one. Okay. He wants the current method. No problem. Do the current method. So current method, you need to find the current. If you go there resistance, this resistance 12. So resistance is 2:1. Hold on. Let me help him. Current, see, resistance ratio is here is 2:1. Yes. So it means your current ratio will be 1:2.
Oh, inversely.
Current ratio will be 1:2. So it means up current will be 1 ampere and down current will be 2 ampere. I will do your way. Okay. But the here total current will be again 3 ampere. Put the values, my dear. So up is also I square R. Down also I square R. Put their values up. So up is 6 ohm. The 6 ohm current is 2 times 6. 2 ohms current is 3 square times 2. Okay. Calculate, my dear. Good, my dear. It's good. So idea was, it's a good question. It's an indirect question, but it's not very difficult. I will rate it MOT, the medium order of thinking of question. You just need to find current and put the equations, my dear. Okay. Question number 31, my dear students. The manufacturer recommends that the longer extension cord you use in an electric drill, the bigger the cross-section area, bigger cross-section area should be used. Why? Let's think. If you use more cross-section area, its resistance will be less. But it is longer extension. The longer mean more length will cause more resistance. So, if the longer, so it should be bigger area. Let's see what is the question. What is the reason? Resistance is inversely proportional to both length and area? No. Wrong option. Not inversely to length. Resistance inversely proportional to length? No. Resistance is directly proportional to length? Yes. Area? No. Since option A, B, C are wrong, so D is correct. Directly proportional to length, inversely to area. It's an easy question. This is LOT. LOT questions are called lower order of thinking questions. You will have maximum of like 20% or 25% questions of lower order thinking. The maximum questions, 60 to 65%, 60% questions are MOT, medium order of thinking. Median mean you need to read the question, you need to apply a concept, you need to choose an equation, indirect, then solve. This is easy question. Question number 32. Question 32, my dear students. You have two batteries, as you can see. The battery one has EMF 12 and other has internal resistance 0.3. Battery one. Battery 2 is 9 volt with the internal resistance 0.1, as you can see. What are the EMF and internal resistance of a single battery that has same effect? Easy, my dear. Just combine. Are the polarities same direction or opposite? This is plus minus, this is minus plus. So it will be 12 minus 9, 3 volt. 12 minus 3. Are they in series or parallel? Series. Series resistances are added. 0.3 plus 0.1. My dear student, this is lower order of thinking question, a very straightforward question. Were you able to do correct? Question number 33, my dear students. 33 says figure shows a circuit. What is the reading on voltmeter? Just apply Kirchhoff's second law to find current, and then you can find voltage. E is equals to IR plus IR. Yes. Kirchhoff's second law. EMF is equals to PD. Yes. 6. I is common factor. 2 plus 0.1. 6 is equals to I. 2.1. Yes, my dear students. So first find current. Okay, so V is equals to IR. But I don't want you to do this way. The answer is? Students, can we do potential divider formula? It says 2 over 2 plus 0.1 multiplied by 6. Alatul 5.7. Do potential divider formula, my dear. This is easy. No need to do Kirchhoff laws. Potential divider formula I used. R1 over R total times V total. Easy. It's B. Question number 34, my dear students. In which circuit? Okay, circuit, the cell has negligible internal resistance. Which diagram shows the potential divider? Okay, IGCSE, not IVA. 35. A wire carries a current 0.1 micro. Potential difference is 10 milli. How much energy? Easy. IGCSE style question. So E is equals to VIT. It is lower order of thinking. Voltage is 10 milli. Current is 0.1 micro. Time is 10 seconds. Just solve it. It's very easy question. It is 1 into 10 power negative 8 joules. Yes? So let's divide by 10 power minus 9. It is 10 nanojoules. Good. Prefixes are tested. Prefixes are tested. By the way, dear students, you know, whenever you want have such a question, you want alatul prefix, don't do anything. Press the key E and G. Press E and G, it will start giving you the multiples of 3. Then calculate and press E and G. After calculating, there is a key above that button 8. Calculate and press E and G first. You will get directly these prefixes. Because 1 peak, you are mixing up. 1 pico mean 1 into 10 power negative 12. Yes? 10 pico mean 10 into 10 power negative 12. 1 nano mean 1 into 10 power minus 9. 10 into 10 power minus 9. This is the same number as this. And you know what you are asking me? You are not listening to me. I am saying once you got this answer, just press E and G, it will tell you what to choose. 10 into 10 power negative 9. Yani 10 nanojoules. Alatul option C. D, I mean. Question 36. What is the definition of potential difference? Easy. LOT question. Potential difference A, my dear. Very good. Why did you choose A? Because it is the energy transfer per unit charge converted from electrical to other forms. Easy. Very easy question. 37. Symbol N. N is the number of charge carriers per unit volume. Number of charge carriers per unit volume. D. N is number of charge carriers per unit volume, my dear. Is D also easy question. 38. Cell has negligible internal resistance and connected across R1, R2, R3. The cell provides the power to the circuit and power dissipated is in the resistors. which word must be correct? Word equation must be correct. Yes, as per this situation. So let's go for one by one. Power dissipated in R1 is equals to power dissipated in R. Let me tell you it is. Are they identical? Yes. So this is the total power dissipated by the battery. Yes or no? Which will be dissipated here plus here plus here. That's it. Power supplied is dissipated in the circuit. Actually, the answer to the question is in the statement itself. Power is provided by cell, dissipated in. So total power of the battery is equals to total power dissipated in 1, 2, 3. Very low order of thinking question. So is there any option matching with this? It's very easy question. LOT, my dear. Question number, yeah, I can see this is a diode graph, yeah? Okay, question 39, my dear students. It says the fixed resistor and a diode are connected in series to the battery with the EMF 6 volt. Negligible internal resistance, the graph shows the variation. The current in the diode is 40 milli. 40 milli. Let's go to the graph. Yes. Here is the voltage. Yes. So the question is, what is the resistance of fixed resistor? No problem, my dear. How much is this voltage? You can take any approximate value because this is 1.25. So it is less than 1.25. Yani, there will be no two similar options. Don't worry about that. So how much is the voltage? Okay, no problem. So voltage across the diode, 1.2 volt. So if this is 1.2 volt, across the resistor will be 6 minus 1.2, which is 4.8 volt. Yes, so resistance will be V over I. I how much? 40 milli? 120. A very good question. This is 1.2 volt for diode. So the other one is for the, what do you call it? Resistor. You can do, my dear, but still it is the same thing. Yes, Kirchhoff law, very good, excellent. Do it. Second law, you mean, right? Good. Okay. Next question, number 40. Electrical cable consists of 7 strands of copper. Put double star on this question. Such questions are called higher order of thinking. My dear students, it's 100% certain that 16 to 20% questions have to be HOTs. Means 20% mean 8 questions. 16% mean almost 6 to 7 questions. So 7 to 8 questions have to be difficult question in your exam. This is one of them. You have a strand of 7 cables. 1, 2, 3, 4, 5, 6, 7 cables. Each cable has diameter, this one. They are in parallel. The resistivity is this. Current in the cable is 30. Potential difference between the 2 points on the cable, which are this apart. Now, what can you do? One of the option is divide by 7 the current. You will get current in one wire. Understanding or not? This is one of the option. Because they all are in parallel, they all are identical cables. So if they all 7 are parallel, so the current in each will be what? 13 divided by 7. Yes? So the problem is you want to find what do you call it? Yeah. So the voltage we also don't have. The problem. Yeah, I mean resistance you don't have. But resistance you will find using resistivity. Now resistance is rho L over A. It needs a lot of space. Can I use this area? Resistance is rho L over A. I'm going for each wire. For each wire. Resistivity is 1.72 10 power negative 8. L, how much? 1 over area of cross section is pi d square. Each cable how much? 0.3 milli square over 4. This is the resistance of each wire. How much?
0.243.
Exact?
0.243.
Then don't round for me, my dear. Why you didn't say 3?
3.
Okay. V is equals to IR. I is 13 by 7. Yes? 13 by 7. Resistance is 0.2433. C. Question number 41, my dear.
That's it.
Let's read question 41. A cell has internal resistance connected to AND switch, variable resistor. A voltmeter is connected to the terminals of cell. Yani, terminals of cell mean terminal potential difference. When the switch is open, the voltmeter is this. Open switch means this is EMF. This is EMF. And when it is closed and variable adjusted so that the resistance of external resistance is this, terminal voltage is this, internal you want to find. Yes. Well, okay. Here first you need to find current and then EMF formula. Step 1, my dear students, current V over R. How much?
0.1875.
0.18. Okay, now you can find internal resistance. E is equals to terminal voltage plus IR. So R will be 1.5 minus 0.75 over 0.1875. Absorb this information. Hurry up. First, we use the terminal voltage and external resistance to find current. And then we use the E is equals to V plus IR equation to find the next question, my dear. We will have a break once we finish 64 questions before we start the next. Question number 42. Student, this is the first time I saw exact same question is in a different year. Yeah, usually exact same questions are not there. Either the options are changed, switched, or the values are switched. So it is the same answer. D. Question number 43, my dear. Finally, the potentiometer's movable contact also came. Question number 43. A battery is connected to the potentiometer. The potentiometer consists of uniform resistance wire, sliding contact P. The potential difference V across the sliding contact and end Q is measured using voltmeter. Sliding contact P is moved to the end Q to R. Sliding contact P is at a distance D. Which graph shows the variation with the potential difference? This you already know. The V1 over V2 is same as R1 over R2 is same as L1 over L2. So they are directly proportional. They are directly. So directly proportional graph has to be straight line passing through a region. I rate this question as easy question. Potentiometer, you wrote these three equations. So actually I taught you this way. V is proportional to R is proportional to L. So V is proportional to L. Straight line passing through origin. Easy, my dear. No waste of time. Simple question. Question number 44. This is a good question, my dear. Let's see what is this question about. In the circuit shown, the cells have negligible internal resistance. The reading is 0. 0 reading, actually, I taught you a null condition. So null condition mean voltage up is equals to voltage down. Okay, let's start this way. So let's find voltage up. How much? Yeah, I mean voltage on the upper terminal is same as voltage on lower terminal. Okay. So upper terminal I'm finding, it is potentiometer, a potential divider 9 over 9 plus 3 times 4. 9 over 12 times 4, 3 volt.
3.
Okay. If V1 is 3 volt, it means V2 is also 3 volt. Now go down. Now I am on the lower circuit. So if R2 voltage will be how much? 9 minus 3 is equals to 6 volt. Now you can use the ratios. Yalla. R1 over R2, V1 over V2. 9 is the lower EMF. R1 over R2, V1 over V2. 36 over 3, 12 volts. Is there any option? Dear students, please take a while, all of you, to just absorb this information. It's not that complicated. Null condition means the voltage at the upper terminal is same as at the lower. Upper, we use the top circuit. Top circuit gave you how much? 3 volt. So if this is 3 volt, so down 6 is also 3 volt. If this is 3 volt, the R will be 6 volt. You can do this. A very good question, my dear. Students, our current carrying wire has I is equal to A and VQ. It's a repeated question. N is a number of charge carriers per unit volume. Again, it is per unit volume. It's a repeated question. Okay. The number of free electrons passing a point in 24 hours. Okay. Number of free electrons is not lowercase, it is uppercase. Okay. The time is 24 hours. You will multiply by 3600 average current. Q is equals to NE. Q is equals to IT. Yes, my dear? So I will be NE divided by T. N is 6.0 times 10 power 23. Avogadro's number. E is 1.6 into 10 power negative 19. Over time is 24 hours times 3600. I guess it's 1.1 ampere. Next question, number 47. In the circuit shown, the lamp P is 250 volt, 50 watt. Lamp Q, 250 volt, but 200 watt. Not possible. There is a reason. It is not possible to have normal brightness. My dear, they are connected to 250 in series. Do you think they will get 250, 250? I mean, not possible to have this rating. Okay. My dear, I am telling you, how do you think the series both will get 250, 250? Anyhow, let's see what's the question. Assume that the resistance of each lamp remains constant. Which statement about accurately describe what happens when switch is closed? P emits 4 times as much power as Q. We need to find. We need to. Don't say, sir, yani this. Actually, P looks 1/4. P looks 1/4. So, my dear, it's not that easy question. Power now emitted will depend upon how much current do they receive. How much current? Let's find their individual resistance. P. Yeah, we will find how much is the resistance. So R is equals to V square over P. For P, it is, sorry? Yeah. So 250 square over, it's a normal yani, over 50. The resistance of P is how much? And here resistance of Q I will find. 250 square over, it's a good question, a very good question. Let's see if anyone was able to even solve correctly. Naam kam?
2.5.
Now the power dissipated. What is same for both of them? Current. The voltage they will not get. I already told you, not possible.
Oh, okay.
Voltage not, my current is same, they are in series. So P is equals to I square R. Current is same. So power emitted will be directly proportional to their resistance. So P has more resistance, more power. So take the ratio. 1250 divided by 312.5. How much? This is up is what? P, down is what? Q, 4. So P has 4 times more power dissipation than R. Option A. A piece of wire has a length of 0.80 meter and a diameter of 5 into 10 power minus 4. L, D. What is the resistivity? Okay. Resistivity rho is equals to RAL. Yes. Which is, we can find the resistance first. Resistance is V over I, 10 divided by 5, 2. So 2, area is pi d square. D is d 5, 10 power negative 4 square over 4. Pi d square over 4. Over length. What's the answer? Question number 49, my dear students. 10 cells are combined. What is the combined? Just check the polarity. If anything is negative, opposite, you will subtract. Add, 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 add. Same polarity. Keep adding. Last is opposite. Minus. So total are 10. So 9 are added and 1 is subtracted. So 12 volt. Dear student, you have to be careful. They may switch any of them in between. So you need to really look. Those with which are with the same polarity, we keep adding. With opposite polarity, we subtract. Ismail? Good question. Let's see how you did this question. Question number 50. A cell of EMF E, internal resistance R, is connected to the variable resistor. Okay. The resistance of each variable resistor is gradually increased from variable R to 3R. From R to 3R. Okay? You increase the resistance. Now, question is, which graph shows the variation of potential difference across the internal resistance as it changes? Students, I want to shortlist 2 options for you. V for internal. X-axis is V for external. Yes? Understanding or no? So what will happen? Dear students, I will explain you now here. First of all, EMF is equals to V plus IR. Yes? I want to tell you, it's your maths. Yani external plus internal is equals to E. Yani Y plus X is equals to constant. If you know maths, Y plus X constant graph is what? A straight line with decreasing gradient. Okay, you can shortlist 2 options. Option B and D are wrong.
Why? Oh.
I already told you the graph should go down. This is the first concept. Okay. Now the second concept is, okay, so either it is A or it is C. So based upon that, they say internal resistance is variable resistor is, sorry, thank you. The variable resistor is increased from R to 3R. So when we increase the value of variable resistance, what will happen? We have two options. Now stay with me. What is y-axis? Internal. So I will make the subject IR. Okay. So IR will be E minus this. Yes. So IR is equals to E minus I capital R. I capital R. So now capital R, you are what? Increasing. Yes. So it means the y-axis will be decreasing. Because the quantity to be subtracted is more. So difference will be less. Yes. Now when their resistances were equal, so PD was also equal. So initial was this one. PD was same. And after this, it should start to decrease. So which one is started to decrease after this? Option A. Next question. 51. 51 is Kirchhoff's two laws are there and some quantities are conserved. First law. First law is the current law, my dear. Sum of currents entering into a junction is equal to sum of currents leaving the junction. Or algebraic sum of all the currents meeting at a point is 0, my dear students. Okay? Yes or no? So, my dear student, option either A or B. And the current law is the conservation of charge. So, conservation of charge is A. Question number 52. A cell has an EMF of 8 volt. Negligible internal resistance. Okay. The reading of V1 is 4. Write it 4 volt. So this is also 4 volt because total is 8. What is the resistance? R. No problem. Find this. So 4 divided by 2. If this is 2 ohms, so this will also be 2 ohms. Why? Because V1 over V2 is equals to R1 over R2. So 4 over 4 is equals to R1 over 2. So it is 2 ohms. Easy question. Voltage share are equal, so their resistances are also equal. So answer is 2. Question number 53. Question 53. Question 53 is the not repeated, but I will just give you the name of each. The graph which bends away from voltage is the thermistor. The graph which bends away from current is a filament or heater. The graph straight, it is metallic conductor with fixed resistance. It is also called ohmic. Having intercept is called semiconductor diode. The previous question which we did, all were VI graphs. These are all IV graphs. So now you understand? Sure? My dear, today at the end of these 64 questions, you will not have anything which is left in the electricity. The table shows the properties of two wires. Okay, those who want to copy their names, you can copy. I'm reading the question. Two wires, P and Q, my dear students. Wire P has cross-section diameter D, and what is the diameter of Q? I can easily relate with the resistivity equation, my dear students. This is for the wire P. This is for the wire P. And I will write in terms of diameter. Okay, this is wire P. No, P. I'm just making the D square subject. 4 L rho over pi r. Okay. Now go for the other one. Hi, other one will be d dash square. Okay. Yes or no? Put the values. 4 instead of L, I will say 2L. Rho, I will say 1 over 3 rho divided by pi. R, I will say 1 over 4 R. I don't like it. So d dash square will be, just take those numbers out. 2, 1 by 3, 1 by 4. Remaining is 4L rho over pi R. Give me this number.
Which one?
This, the factored.
8 over 3.
This
8 over 3.
8 over
3.
3. Take square root. Huh?
1.63929.
63. 8 over 3 square root. Yeah, it's a very boring question. Question 55. A cell contains, a cell has a constant EMF. A variable resistor is connected between the terminals of cell. The resistance of variable is decreased this time. When the resistance is decreased, total resistance of circuit will be less. So it means current in the circuit will be more. So more current means PD loss in internal resistance will also be more. So terminal voltage will decrease. So which statement about the change in cell's terminal potential? I already told you. It will decrease. Terminal potential will decrease. Yes. More work done in moving the unit charge. Khalas, this is the answer. They say current has decreased. I already told you current is increased. Option is A. Question number 56. Kirchhoff's two laws of the electricity can be derived from using conservation. The first law is charge, second law is energy. Easy question, 56. 57. Both laws. First and second, both we will apply. The battery of EMF 10 volt, internal resistance is R, connected to three resistors, 2 ohms, 15 ohms, and R. A current of 0.45 ampere is in the resistor 2 ohms and R, and 0.48 ohm is for the 15 ohms. What are the values of R and R? My dear, both laws. First use Kirchhoff's first law and then second law. No, single equation. Loop I will use. I just need the first law. First law says current entering is equals to current leaving. So current is 0.45 plus 0.48, which is 0.93. Okay, right here 0.93. Okay, now apply, my dear. Direct question, my dear. This loop to get internal resistance, okay? So sum of EMFs is equals to sum of PDs. In this green loop, EMF is 10. PD down is 0.48 multiplied by 15 and up is 0.93 multiplied by R. No need of simultaneous. Please calculate R. Three ohms. Okay, done. Now green loop is done. We will use the other one. Okay, now use the small loop. The upper loop. I'm using this loop now. Okay, using this loop, my dear, again sum of EMFs, 10 volt, PD, I is 0.45 times R plus 2, 0.45. No, I is different for internal resistance.
0.45 plus 0.3.
2 and plus internal resistance we have 0.93 times 3 ohms. Solve it. Are you sure? 20. So first I did this part and then I did this part. You can absorb the information. Actually, step 1 was this one. Let's go to question 58. 58, a battery of negligible internal resistance is connected in series with the thermistor and fixed resistance of 2 kilo. Okay. They say at temperature 20, the resistance is 12 kilo and temperature 50, resistance is 5 kilo. Potential difference of V out across the fixed resistors is 4.5 at 20. What is at 50? Let's go at 20. At 20 degrees, my dear, the resistance is 12 kilo ohms, yes? And V out is how much? 4.5 volt, right? Yes or no? So let's find EMF. Let's find EMF. So total resistance how much? 24 kilo. This is easy. So it means this voltage will also be how much?
1.5 volts.
So if resistances are same, the voltage is also same. So this gives you EMF. So EMF is 4.5 plus 4.5. Really? Oh, wow. How you got 9? MashaAllah. Now, since you got EMF done, now I'm going to use a green color for 50 degrees. The up voltage is resistance is 5 kilo. So I will use the potential divider. 12 divided by 12 plus 5 into 9. 12 over Sabanashar into 9. Calculate. Okay, so what's the answer? 6.35. Question number 59. What are the definitions of PD and EMF? Both are amount of work done per unit charge. Both. Work done per unit charge, work done per unit charge. The difference is energy converted from electrical to other to electrical. It's easy. The diagram shows a network consisting of 3 resistors. Okay, actually here numbers are missing. Please fix X and Y combined resistance. So first we go parallel. Parallel is 1.2, 4.7, 1.2, 4.7, which is 3.2 kilo ohms. Okay. So total resistance will be 2.2 plus 0.9559 kilo, which is 3.2 kilo ohms. Question number 61. A resistor dissipates 25 watt of power across its resistance. This is easy. P is equals to V square over R. R is equals to V square over P. 16 over 25. 0.64. Easy. Question number 62. A diagram shows a cell with internal resistance connected parallel to the fixed resistor. The resistance of variable resistor is decreased. It's quite similar. Whenever any resistor of a circuit is decreased, the total resistance of circuit will decrease. Current in the circuit will increase. PD loss will increase. So terminal voltage will decrease.
Yeah, how do you
Less resistance, more current, more PD loss, less terminal. It's a sequence. صح ولا غلط? Question number 63, my dear. Okay, the radioactive particle alpha produces a beam of alpha particles. The average current is this, I. The beam is incident on the metal plate. What is the average number of alpha particles? Capital N. Okay. The time is this. Okay. So, my dear, you know Q is equals to, I don't want to find. I is equals to Q over T. So, charge will be 1.5 into 10 power minus 9 into 3. Charge is 4.5, 10 power minus 9. Now, actually, there is a problem. The alpha its charge is 2e, 1 alpha. Okay, so 1 alpha, the charge is 2e, yani which is 2 times 1.6 into 10 power minus 19. So 1 alpha, the charge is 3.2 into 10 power negative 19. How many alphas charge will be 4.5 into 10 power negative 9? Cross multiply. See, 1 alpha charge is not E. That is for electron and proton. 1 alpha charge is 2e. Okay. Question number 64. It says the charge carriers in a metal wire are free electrons. Which statement about charge carriers of each free electron is correct? Charge of each. Charge on each electron is constant. That's it. Just look, is there any option? Magnitude of charge increases. La hawla wa la quwwata illa billah. Magnitude of charge can be 0. No. Independent. My dear, charge on electron is constant, my dear. It is